Hey Tree class, let's look at how to plot these numbers in the complex plane and then switch them to polar form and then exponential form based on the rectangular form. So when I'm looking at this, I have to go 11 units in the real direction and negative 11 units in the imaginary direction. So that means I'm going to be down here in quadrant 4. So 11 units in the real direction would be right there. Negative 11 in the imaginary direction would be right there. Alright, so once I have it, make sure it stays where you want it to stay. Once I have it where I want it, I check my answer. So there's 11 minus 11i. Alright, and now we need to write it in polar form. Okay, polar form means we're going to have a number out here, which is how far this number is from the origin, and then the cosine and I times the sine of the angle. So it's going to be this top form. I is not with cosine, so it's definitely not B and C, and they're not both sines, so it's definitely going to be A. But we need to find the distance this thing is from the origin. That's what goes outside, and then the angle that gets us there. And we typically write this as a positive angle between 0 and 2 pi. Alright, so R, how far it is, the magnitude of this thing, is equal to real parts of this squared, like the Pythagorean theorem. So 11 squared plus negative 11 squared. Alright, so 11 squared is 121. Negative 11 squared is also 121. So this is the square root of 242, which 11 squared, 121, is a factor. So I could write this as 121 times 2, both underneath a radical, and then that's 11 times the square root of 2. So that's what's going to go here. Alright, and then if I am in quadrant 4 and the x and y coordinates are opposites, so positive 11, negative 11. If you look on your unit circle, that is 315 degrees, or equivalently 7 pi over 4 radians. So that's the angle, or what we call the argument when we're doing polar forms of complex numbers. So those are the values that are going to go in here. Alright, use angle measures greater than or equal to 0, less than 2 pi. So we're not using degrees, so we are going to use the 7 pi over 4. So I'm going to click A. That was 11 times the square root of 2, and inside that's going to be 7 pi over 4 for both of these. So that's the polar form. And then once I have the polar form, I basically have the exponential form. All I have to do is grab the number that's out front. That's still going to be in front of the e to the power of, and then it's I times the argument, I times theta. Alright, so there's what I wrote, 11 square root of 2 e to the power of I times the angle, the 7 pi over 4 from the previous answer. So once you get the polar form, you have everything you need for the exponential form. You just got to get everything in its right place.